Right, let's have a look at differentiation, and the first section we're going to do is called the average gradient. Right, now before you can do any questions, it's important that you know the following. Right, we do have a parabola intersecting with a straight line, and the question will be to work out the average gradient between points P and Q. Right, now first of all, we need to find X and Y coordinates. Okay, so let's say, for example, let's call Q at this point, let's call it, let's say A. Right? And P at this point over here, let's call it A plus H. Why A plus H? Because if this is A over here, and let's say you progress a H distance, then this point over here will be called A plus H. Right. That's on the x-axis. On the y-axis, if this point is called A, then we're going to call this point on the y-axis f of A. Okay? If this is called, the second x value is called A plus H, then we will call point P across the f of A plus H. Right, so we're always going to do that. If we recall, at some stage you did, for example, let's say, a parabola equation where you said y is equal to, let's say, 2x squared plus 3x minus 4. But if you can recall, you can also write it as the f of x is equal to 2x squared plus 3x minus 4. Okay, so as you can see on my graph here, on my x-axis, A will be the f of A on my y-axis, and the A plus H on my x-axis will be the f of A plus H on my y-axis. Okay, so we're always going to use these coordinates. Right, now, if you think back a bit, you'll remember that to work out the gradient between 2 points, we actually used the formula m is equal to y2 minus y1 divided by x2 minus x1. We're still going to base our average gradient on this gradient formula. Okay? The only difference is now we're going to say, I want to work out the gradient between points P and Q. Okay, the average gradient between points P and Q. So the best way to write it is to say then, right, I want to work out the gradient of PQ. Okay, no problem. Now, we know that the gradient is y2 minus y1 over x2 minus x1. Okay, now if you look at your graph, you'll actually see that your y2 value on the y-axis is actually the f of a plus h. So let's substitute y2 over here with f of a plus h minus, okay, where's my y1 value? That will be the other y value on your y-axis, which is actually the f of a. So let's substitute in our formula y1 with f of a minus, we substitute y1 then with f of a. So all of this information comes from your graph. Okay, so we all get it from the graph. Alright, then at the bottom we have x2. Now we have to go to our x-axis and let's see where's the x2 value. Now if you look carefully you'll see, okay, wait a sec, it must be the value over here. That will be the x2 value. So let's substitute x2 with a plus h. A plus h. And put it in brackets. So that you can clearly see that your x2 is actually a plus h. Right, let's put the minus down. Okay, we still need to find the x1 value. And on my graph, there's my x1 value lying over there, which was called a. So we just substitute a into x1. Right, we can simplify this formula, but for further examples and illustrations, I want you to keep this formula. Don't simplify it. Okay, it will be easier to use it in the upcoming examples. Right, so my formula to work out the average gradient, in this case for line PQ, or between the points PQ, we're going to use this formula. Right, let's have a look at the example here. Number 1, the f of x is equal to x squared plus 3x. You know that's a parabola equation, right? And then I say determine the average gradient between the points where x is equal to -1 and x is equal to 2. Right, let's put it on a sketch. Where is x -1? Okay, let's assume it's around there. So that's -1 and x equal to 2. Approximately around there. Just a rough sketch.